Hey everyone. So now that you have reviewed how to graph exponential functions, including with asymptotes, let's talk about what it means to calculate an exponential regression. So the word regression may sound familiar because in the past we have done what we call linear regressions. So a linear regression is when we have a set of data, and let's say we plot our data on a scatter plot like this, and we want to calculate a line of best fit. If we are doing a linear regression, though, what we are doing is we are saying what line best approximates this data if our line is in the form y equals mx plus b. So a linear regression will assume that you want a straight line. It assumes you want a linear equation to fit your data. An exponential regression is doing the same idea, but what if we were modeling data that we are expecting to behave in an exponential fashion? So maybe our linear regression was showing over, like, as temperature changes, how much ice cream changes or something like that. But perhaps we're trying to model the population growth of rabbits. Or something like that, where we know that an exponential model would be more appropriate because we're having repeated multiplication. So let's say that this is our rabbit population, and as scientists, we've been kind of like tracking the rabbit population over time. We don't want to do a straight line of best fit because this is not a relationship that behaves in a linear fashion. Instead, we know this is an exponential relationship. So we want to calculate an exponential best fit. If we are trying to model data, imperfect data, with an exponential function, then we are going to do an exponential regression. So the procedure for doing this would be in your calculator, just like you used to do with linear regressions. You're going to go to Stat, Edit, and you're going to put your x values in L2, L1, and your y values in L2. And then you're going to, once you've entered all of your values, you're going to calculate. And instead of choosing a linear regression, you're going to choose an EXP reg, which stands for exponential regression. This will then give you an A value and a B value that approximates your data rather than a linear line of best fit. So let's take an example here. This table shows the number of new stores in a coffee shop that opened during the years 1986 through 1994. Then we have a table of values using x equals 1 to represent the year 1986 and y to represent the number of new stores. Write the exponential regression equation for these data. Round all values to the nearest thousandth. So why would we want an exponential regression here instead of a linear regression? If we think of new stores opening, it's kind of like a viral tweet. The stores start small, but then maybe each year they are doubling. And if they double one year and then they double again and then they double again because their business keeps getting more popular, then their growth is going to be exponential. It's not going to be linear. They're not necessarily just opening 5 stores a year. And we can kind of see that in our data. It's starting by, like, it's not really doubling, but by the end, it's going from 400 to 680, whereas at the beginning, it was just going from 14 to 27. So the key here for our procedure, though, is notice that they say use x equals 1 to represent the year 1986. Very often in exponential regression, our x values will be years, and we want to reset our starting point to be whatever year we are considering the start. So here they instructed us to make year 1986 1. So when I type this data into my calculator, I'm not going to type in 1986, 1987. I need to type in 1 through 9 because that represents years since 1986. So this will be my L1, this will be my L2, I'll type those in, then I'll go back to calc, exponential regression, and that will give me a screen that looks like this. I'll see the structure of an exponential model. They tell me A equals, you should get 10.59599 ... B equals 1.5862 5 ... And then they give you your R squared value and your R value. Remember that your R is telling you the strength of the fit, but they did not ask us this in this case. So if I want to put these into the nearest thousandth, then my exponential regression equation would be y equals 10.596 times 1.586 to the power of x. And just like I can find a line of best fit, this equation models how this coffee shop is expanding. So what does this mean? This means that my store, the coffee chain, started with approximately 10 stores, right? And each year since 1986, we're multiplying by 1.586. So we could say each year since 1986, the brand is growing 58.6%. So my growth rate would be 58.6%, and that is approximately how much this store is expanding each year. So in short, an exponential regression is exactly the same as a linear regression process-wise. It just gives us a different story to tell about the data that is sometimes more appropriate. One thing to highlight, I do bring this up later in the problem set, notice that an exponential regression always assumes an asymptote of 0. So in a TI-84, they're only going to give you an A value and a B value. There will not be a K. So all exponential regression equations have an asymptote at 0 if you expanded them into infinity. They're never going to give you an asymptote to model the equation.